Okay, so I'm going to walk us through how to solve for the discrimination index. So I've got the formula written at the top already here, as you can see. And the formula is the rate of responding during the discriminative stimulus, or SD, divided by the combined rate of responding during the discriminative stimulus, or SD, and the S delta, or extinction stimulus. So I have written down where it says SD equals 0.46. That's the rate of responding during the discriminative stimulus. And then S delta equals 0.22. That's the rate of responding during the extinction stimulus. So from there, I'm going to fill in the values of our problem. So SD rate would be replaced with 0.46. And that SD rate here, again, same value, 0.46, plus the S delta value, which is 0.22. Perfect. So from there, I'm going to actually start to solve those different components. So first I will do, I like to rewrite the problem every time just because I'm showing my work. 0.46 plus 0.22. So you add those two together, you get 0.68. And we're doing that first because we always want to start with our parentheses, just from an order of operations standpoint. So now I'm going to have 0.46 divided by 0.68. And I can't do that one in my head, so let me just whip out my calculator real quick. 6 divided by 0.68. Okay, so once we divide those numbers, the answer is 0.676, so I'll go 0.68 with standard rounding rules. So the discrimination index for that particular example is 0.68. So if you recall, the discrimination index ranges from 0 to 1, with 0.5 being like no discrimination or equal responding across both components. So this is nowhere near perfect discrimination, but a bit above no discrimination for the SD. So let's walk through one more example. So I will shift these values around a little bit. In this case, we'll have maybe a bit higher responding in the SD. So above 0, like above 1 instance per minute, which just to show you that that will also equal out to about 1, to a value between 0 and 1. Okay, so if I were to do the same thing with these values, I'm going to start in that same place by subbing out my values. So the discrimination index equals SD rate, which is 4.35, divided by the SD rate. So again, 4.35 plus 1.31. Solve for my parentheses first. I'm going to do that on the calculator just to be sure I don't make any silly math errors. So I'm doing 4.35 plus 1.31 equals 5.66. So now I'm going to take that 4.35 divided by 5.66, and we get 0.768, so 77. So this is a stronger discrimination because more of the responding is allocated towards the discriminative stimulus relative to the S delta. So when we're looking at a discrimination index, it essentially just tells us the proportion of responding that is allocated to the stimulus that is actually associated with reinforcement. Cool. Hope that helps.